What you'll be measuring today in the heat exchanger lab is the effective flow rate for the hot and cold water and how that affects the heat exchange inside the heat exchanger, and also measuring kind of theoretical pressure drops, and that actually correlates back to what you're expecting to get. And so that's actually the trickiest part of this experiment, is measuring the pressure drop accurately. There's a few complications that you may run into, so we'll go over that in this demonstration. Before we get started into showing you how to measure the pressure drop in the heat exchangers, I just want to go through a few things that'll be in the interactive lesson plan just to refamiliarize yourself with everything. To change from concentric or from counterflow and co-flow, that'll be done here. Again, that's in the interactive lesson plan. And then to change the flow rate is just simply here. So this is the cold water. Just simply twist the knob and kind of keep track of where this little measuring apparatus is inside the tube. Similarly for the hot water, just turn it up and down. And yeah, so that's how you adjust the flow rates. So to change or to measure pressure drop in the heat exchanger, we use these connection lines. Basically, there's a set for the cold water and a set for the hot water. To change these out, it's not too difficult, but it's definitely worth taking a look at through this demonstration. Basically, each one of these connectors, you slip up the outer sheath, it pops right back out. And then let's say we want to go from this heat exchanger, we're done measuring the pressure drop here, we want to measure the pressure drop on the concentric heat exchanger. We then move the lines over, you pull back the outer sheath there, you make sure that it's all the way in, and then you let it go, and then just check it to make sure that it's snug and there's no leaks. And so again, it's the same thing on both the inlets and the outlets. Pretty straightforward, but again, if you have not seen this before, it might look completely foreign to you. Okay, so that's how you go from one heat exchanger to the other in terms of switching out the pressure lines. So when you do that as well, you want to close off the valve so no water is flowing through that particular heat exchanger, and then you want to turn on, or you want to open the valves to the heat exchanger you're about ready to measure. So right now this valve is closed. You want to open that up for the hot water, open it up for the cold water, and then likewise in the back, open up the outlets for both the hot and cold. Actually, it's this one. And that's how you do that. Okay, so now what we're going to do is we're going to show you an issue that you may have when you're doing your pressure drop measurements with air bubbles getting in the lines. Now, if this happens, there'll be somebody in the lab to help you out with it in case you're not 100% sure what to do. And if you don't know what to do, please ask, because we don't want water spraying all over the lab. But we'll go ahead and set that up for you on the heat exchanger, the shell and tube heat exchanger on the far left. So let's move the lines back. So let's close these guys again, and we'll move it back over that way. So close this, close that, and then grab that one. All right, so once the pressure lines are hooked up, again, we already shut the flow off of this heat exchanger. We're now going to open the flow back up to this one. And what you'll notice, for example, this is clearly evident right here, is that you get large air bubbles in your pressure drop lines. And if the pressure drop lines aren't full with water, you're not going to get an accurate measure of the pressure drop across the heat exchanger. So to do that, you can bleed out the air bubbles that are in the lines either through this, opening up the valves on this end, or opening up the valves over here on this end. And we'll show you how this works over there. All right, so again, there's air bubbles in the line right now. To clear those out, you have to play around with the pressure inside the line. So one of the tricks is to open up the area where it's measuring the pressure drop. So if you can go ahead and do that right now. It's open? Yes. Okay, I'll open up my end. It'll start pushing water through. If it looks like there's water leaking, it's not that big of a deal. It'll eventually, stop leaking. And now you can see that there's no bubbles in the line at this point. So now you can effectively do an accurate pressure drop measurement. So when you're done doing that, close that off so you're not spilling all the water out that way. And then the other trick that we did is we closed the outflow of the cold water. So you're going to want to open that back up. And then you should be fine in terms of having no bubbles in your lines. So let's just double check that. It looks like we're okay there. There's some bubbles in that one. Do we want to just clear that out real quick? Anytime there's a bubble in the line, all you do, open that guy up, and then I'll open this up, and it just pushes everything right out. and then we'll close that, and then close that, and we should be good. So again, when you're doing pressure drop measurements, it's very critical to get all of the big bubbles out of the lines. If there's some small bubbles left over when you're going through and kind of clearing the pressure in the lines, that's not the end of the world. You'll still get a good pressure drop measurement. And again, there'll be somebody here to help you out with that. So if you're confused about anything, please ask. It's generally not a good idea to start pulling valves open and closed just without any supervision, because you might end up spilling water all over the place. And with that, that's pretty much all you need to know for running the heat exchanger. Again, if you have any questions, someone will be here. But yeah, that's it.